Now, we've done 2 videos so far. One where you were just told what the slope and the y-intercept were, and then you just had to figure it out. And then ones where you had to figure it out from the graph, so you're still striving for the equation. And where this is different is we have this equation instead, and then we have to develop our own graph. And on purpose, I'm doing something different from what the textbook does, because I find that when you're shown different equations, you kind of start doing everything the same way. And then notice that this first one is in slope-intercept form already. The second one, nope, it's not in slope-intercept form. This third one totally is. Fourth one totally is. Fifth one not, and so on. And so what I'm trying to encourage you to do is, pick the choice that is going to be the least amount of work. On these early ones, just for the heck of it, let's pull away what we need. Now, if you're not making an active effort to try and memorize this by now, that's something you need to work on. So here's y equals mx plus b. It just kind of rolls off the tongue. Say it out loud a handful of times. I would never really show this work as I did these problems. I know that I can just take away negative 2/3. If your number in front of the x was written like this, it would be the exact same. If it were written with a negative out in front of the fraction, they would be the same. And I doubt you'd see them written this way, but you could have 2 up top and then the negative down underneath. So all we're doing is pulling the value of m out of the equation. And then b is going to be 1, and then just make sure that it's clear to you that since we're adding, it would stay as a positive 1. If this value was being subtracted instead, it means you'd have to change the sign because of the equation. The equation is written so that you're adding b, so that means that b, as long as it's got to match the equation. All right, so it's easiest to begin with the y-intercept. That's what we've been doing. So with b equaling 1, go ahead and tag your x and y axes, and that means that my y-intercept is going to be right there at that point. And then when I'm looking at this negative 2/3, draw a little arrow here to rise over run, which means that we're going down to, which I'm going to show in red because normally I'm just counting this, I'm not drawing my triangle. So there I'm moving down 2 for the y, so count this as you're doing it, and then running over 3. 1, 2, 3, which drops you right at this value. And for this one, since it's new, kind of make sure that you didn't trip that up. So I went down 2 over 3. With that in place, get a ruler out and make sure your line looks cleaner than mine. And the most big picture check you can do as well, okay, you had a negative slope. Is the line decreasing? It is. Good. Alright, you had a 1. Did you make sure you have a value at 0, 1? Cool. And then if you really want to be thorough, since this is a new concept, here's 0, 1. And here is 3, negative 1. Sorry, my iPad's acting strange. And if you plug that in, both of those values would work out. Moving on. Alright, now this is not in slope-intercept form. And since it's not in slope-intercept form, you really might save yourself some time by doing the x-intercept and then the y-intercept. There's no reason that if it says graph each equation, that you can't just do it your own way. So if it says graph each equation and they tell you to use slope-intercept form, you have to. So don't forget that 3 times a negative 2 would give you a very nice number there. 5 times, that's a little bit uglier to get to the 6. So I'm showing you that you can use the x and the y-intercepts. But you can also rearrange the equation. So let's rewrite this, and let's make use of this space to change our equation. I think it's going to be nice to keep the y on the left side. If I want something to be in slope-intercept form, then the y has to be by itself, as well as positive on the left. So I'll subtract 5x from both sides, leaving me with negative 3y on the left equals negative 5x plus 6 on the right. Dividing everything by negative 3 gives me y equals positive 5/3. I'm just showing those marks to remind you. No need to simplify that fraction, it's already simplified. 6 divided by 3 gives me 2, which means I then have to subtract the 2 term. So I get 5 over 3x minus 2. And then now, you get your y-intercept. It's at negative 2. And since my slope is positive, I go up 5. 1, 2, 3, 4, 5. And then over 3. 1, 2, 3. And then I'll put a closed circle there so that I'm modeling how if you did that and used a ruler, it would be a much straighter line. And here's the x and the y-axis. And you can even label these lines to be more thorough. And sometimes that's good habit, because later on you'll have to solve systems of equations and graph 2 lines at a time, where labeling them helps you tell the two apart. The only thing I'll show you for this is that if you have an integer and not a fraction, sometimes people get tripped up by this. So go ahead and write m equals, well, you know it's 2, but you like to see rise over run, so it rises 2 over 1, and then the y-intercept is going to be negative 3. So I'll put the answer up for this in 5 seconds, give this a pause. There's the work. Pause this to fix it and check your stuff if it doesn't make sense. And then we could also plug in values. If I plug in this value, that would be 0, negative 3. Here's 0, making that term going away. And then I subtract 3 and get negative 3. And then I could plug this in where it looks like it's at 1, negative 1. 2 times 1 gives me 2. Minus 3 does give me negative 1. We're good there. This is also an OYO problem. Same deal here. You don't have to do this when you're showing your work in the textbook, but do it for these notes. 4 seconds until I put the answer up. There it is. And make sure that your line is, first of all, increasing. There's the positive slope, and mine's increasing. And then the other thing to be sure of is, well, let's think about what this means. If you only move up 1 step, but then have to go like 4 feet to the side, this would be a gradual climb. So that if you started to graph it the opposite way, where you went up 4 over 1, you'd probably not pick this up early on, but being thorough and checking it, you'd be like, well, that's too steep, so I think I should fix my work. Now, here we are with one that is actually way more arduous and way more work to do by solving for y, I think. So let's do this the old x-intercept way. And now that we've grown a little bit more confident with this, we know that y has to be 0 at the x-intercept, and we know that x has to be 0 at the y-intercept. And so this means that if I jump right in, my y term is going to go away as I figure out the x-intercept. So if you're confident enough, just write 4x equals negative 12. And then you can just look at this in your head and be like, well, x has to be negative 3. And if I wanted to save some time, maybe I could plot that negative 3, 0 right now. Now if the y-intercept's over there, well, that means that x has to be 0, so that term's dropping out, and that gives me 3y is negative 12, and that y is negative 4. So here I am, 4 down on the y-axis, getting a ruler out and graphing it. Now, I'm going to write the word or, and I'm going to show you how else you would do this. I've done a little bit of algebra to rearrange it so that it's in slope-intercept form. So I do want you to eventually write this after I explain it, so pause this when I'm done explaining. Label that as SI, label this as standard form, so that you're looking back at this and it's a nice reminder. Here's the y-intercept down 4, and then if I count, it looks like we are going down 4 over 3. Were this a test, you could do problems multiple ways. So yeah, pause this, get caught up, and I'll let this be an OYO problem, and you can decide to do it either way. Answer is going up in a few moments. Again, I showed it both ways. Here's using the x and the y-intercepts, where x is 3, and then y is negative 2. And then here is doing a little bit of algebra to figure out that the y-intercept is, oops, I keep on erasing things, sorry, negative 2, and then you're going up over 2 and then 3. Again, here I see a positive slope. I do have a positive line, but that's checking a changed equation. So usually it's better to go back to this, which means it would be nice to plug in the values of 3, 0, check, check, checks out, as well as 0, negative 2, which also checks out. So yeah, graphing, like I said, when you're given problems along these lines and it says graph each equation and it doesn't say that you have to use slope-intercept form, to me, you make more math mistakes when fractions get involved. So I'd say go down whichever path avoids uglier fractions. But you want to be confident in both. It is definitely not one of those decisions where you're like, oh, I'll just be happy with the other ones. No, you have to be able to use both tools.